Hello everyone, this is a video lecture for pre-calculus. We're doing 5.2, sine, cosine, tangent. Boom. Yep. Um, so what I did in class was I talked about unit circle and I went through all these other things. I'm going to give you some formulas and I'm just going to jump right into the homework here in a few seconds, okay? Because I think that it's good to learn unit circle. It's good to start being more familiar with that stuff. But ultimately here in the videos, I'm gonna just do it. That's the point here of the videos. We're just doing it. So some formulas. First off, Pythagorean theorem. Pythagorean theorem. The formula officially is a squared plus b squared is equal to c squared. I often think x squared plus y squared is equal to r squared. We can also say that this is going to be cosine squared plus sine squared is equal to 1. We're not going to use that right now, but all these are Pythagorean. They're all different versions of it. So, well, there you go. So let's talk about sine, cosine, and tangent. If you have a triangle that looks like this, let's say, and I'm going to call this side here the adjacent side because it's adjacent to the angle. I'm going to call this the opposite side because it's opposite of the angle. And this is called the hypotenuse because it's the longest or opposite of the 90 degrees. If that's the case, then sine of theta is equal to opposite over hypotenuse. My cosine theta is equal to adjacent over hypotenuse, and tangent theta is equal to opposite, it's close enough, over adjacent. Okay, these are the big three. I know there's going to be some other ones coming soon, but for right now, that's good enough. Now, what our goal here today is to find these ratios. I'm not going to be explaining them as much. I'm just going to say, hey, we're going to find the ratio. That's just what we're doing. They say find a fraction. We're going to do it. So as your time goes through the rest of this class, I hope that you're acquiring more about why we're doing all these and what they're useful for. I can't give that all to you here in one single video. And I do recommend going back again to my Algebra 1414 video series. Hey, guess what? 5.2. And I go into all that as well in depth. So let's just go do some homework, and it'll be great. So that's the goal here in the videos. Not to go super in depth every single time. We're just going to do it. So the first question has angle theta, and I have a b is equal to 15. I have an a that's equal to 8, and then it has a c, which is equal to, I don't know. Well, first off, the first question is, what's the hypotenuse? What's c equal to? So I'm going to use some Pythagorean theorem to find it. So again, a squared, b squared equals c squared. Okay, so I got 8 squared plus 15 squared is equal to c squared. To solve for c, I'm going to square root both sides. And you're going to get the hang of this like super fast that basically if you're looking for one of the sides, you always have to square root it. If it's going to be one of these and not the hypotenuse, you put a minus sign between them. Pretty easy. Anyways, I put this all into the calculator like all at once, and I got a 17. So there you go. So 17 is the C. Okay, awesome, awesome. And now they're going to ask for sine, cosine, and tangent. Sine, again, is my opposite over the hypotenuse. The opposite of this angle is an 8. The hypotenuse is a 17. You're done. That's it. That's all you got to do. The cosine is adjacent over hypotenuse. And so my adjacent is the 15. And then your hypotenuse is 17. That's all you got to do. And then tangent is opposite over adjacent. Opposite is 8. Adjacent is 15. And that's all you got to do. Okay, we did it. And now they want more. So at this point, they're going to also ask for cosecant, secant, and cotangent. All we're going to do here to go from that side to this side is we're going to flip them upside down. So instead of 8 over 17, it's 17 over 8. Instead of 15 over 17, it's 17 over 15. And instead of 8 over 15, it's 15 over 8. And that's it. So I'm not here to say why. I'm here to say what. And the what is you go ahead and flip them. Okay? That's all we're doing. Okay. So next question. That's what we're doing today is just a lot of what. What do we do in these situations? I have B is equal to 28. I have an A that's missing. And then I have a C that's equal to 35. And they say go. Well, because I'm finding this other additional side, A is going to be the square root of C squared minus B squared if you go and solve for it. It really is like it's just kind of like patterns. You just kind of see it and you just do it every time. It's not hard. So if you're like, how did I get that formula? Well, I just manipulated the original Pythagorean. It was not that big of a deal. So I have 21 now. So this is equal to 21 now. Awesome. Cool. So now they say, hey, find the sine. Find the cosine. Find the tangent. Okay. So sine is going to be opposite over the hypotenuse. 21 over 35. Normally I'd call it there, but my math lab wants you to simplify it. So you put this in the calculator, you actually get 3/5. That's what they're going to want. Okay. The next one, cosine, is adjacent over hypotenuse. 28 over 35. Again, you reduce it down. This happens to be a 4 over 5. And then your tangent is opposite over adjacent. 21 over 28. This happens to be 3 over 4. Cool. Okay, well, there you go. To get the others, you just flip them. I'm just going to write it. Actually, you know what? Yeah, I'm going to do it. But I'm going to do it sloppily. It's kind of like a mini protest. Like, why am I having to do all this? I mean, it's good to do this. It's good to know how this works at this point, but they're totally not useful to you right now. They'll be useful later, but having this flipping numbers thing is whatever, okay? Am I just a bad teacher? So, moving on. Next question. So I've got 5, 2, 9. I've got a triangle that's kind of tall, and they say that this is 60, and that this is 30. I have a 2, a 1, and a square root of 3. And they say, what's the cosine of 30? If you had your unit circle, you could just go and find it. And this is not the lecture on unit circle, but I'm saying it's super helpful. So you can use this triangle, I guess. I don't really want to. Cosine of 30 is square root 3 over 2 from your unit circle, and you're done. But let's just say that we're going to use this. The 30 degrees is this guy. And so my cosine is adjacent over hypotenuse. And so you see that this is the adjacent right here, and there's my hypotenuse. So square root of 3 divided by 2. That's what we're doing. There you go. All right, next one, 5, 2, 13. It says, find the tangent of pi over 3. I mean, it's screaming unit circle at you. Now, it seems that I messed up at one point. I have my notes here, and I like scratched through it and said, I mess up sometimes too. It's fine. I'm going to show you how this works. I don't know what I did wrong, but it's fine. Okay, so what do we do here? My tangent of pi over 3, that pi over 3, you can convert it to 60 degrees. Okay, and then again, I'm going back to unit circle. I don't know how else to do it. Maybe they have a triangle like this. And they say figure it out. That's fine. 60 degrees. And you could say, oh, well, that's going to be the opposite over the adjacent. Again, if you're using this triangle here, so 60 degrees, opposite over adjacent, that would be the square root of 3 over 1, which is just the square root of 3. Done. But if you go back to unit circle, this would actually end up being, if you go back to your formulas here, you would say that this is a sine of 60 over the cosine of 60. Or you could say it's y over x at 60. And so if you look at c to the degrees, you got square root 3 over 2. You got a positive 1/2. The 2's cancel, and it leaves you with a square root 3 again. Awesome. That's it. So I don't know what else to say. Some of these are just, this is what the answer is, and I don't know what else to say besides use your unit circle, use a little picture. It's just practice is all this stuff is. Lots and lots of practice. The only way that you're going to get better at math is practice, and that's what the homework is designed for, is for you to practice this stuff. And that's what I'm doing with you, so that I'm doing it with you, not for you. It's with you, so that it's not overwhelming. I'm not going to give you every answer, but I'll try to do a lot of, good help here. That's supposed to be a theta, but it's just totally too ugly. There we go. So they say find the tangent given all this other stuff here. Well, again, there's a lot of formulas here, but what I'm going to say is that the formula in this case is sine over cosine. And so in this case, again, I got my sine over the cosine. The 17s cancel, and there you go. I think what they wanted you to do, though, was draw a triangle that made sense for this stuff. And so cosine, I'd have a 15 and a 17. 8 would be the opposite. And so then you're saying, oh, my tangent's opposite over adjacent. Wow, go figure. Lots of ways to do this, lots of ways. But I think that either of these is totally fine. Where do we get formulas like this? Well, on the unit circle page on the formula book that is on Blackboard, you on the next page right after that is all the formulas. And so you could just print it. What I do in class is I print out a lot of these copies handed out. But it's all there. Tons of formulas, which we will be using later in this chapter and in chapter 6 for sure. So be comfortable with all those crazy formula things, and this is just one of them. So how do we find cosecant, secant, and cotangent? All we're doing is flipping it. I'm going to take my sine, and I'm going to flip it. So it's now 17 over 8. I'm going to take my cosine, and I'm going to flip it. So now it's 17 over 15. And then for my cotangent, I'm taking it and flipping it. There you go. Whew, lots of practice. Next one, 5, 2, 19. And so I've got, in this particular problem, sine of t is equal to 2/3. And I've got cosine of t is equal to square root of 5 over 3. And they say find the tangent of t. Now, again, I truly think that it's easier to do sine over cosine as your formula here without having to go crazy on a triangle. Just do this formula. It's so much better. So 2/3 over the square root of 5 all over 3. The 3's are going to cancel. You get 2 over the square root of 5. Now, traditionally, anti-traditionally, that's a perfectly great answer. But traditionally, we need to rationalize denominator. If this is the first time that we're doing this, which I think it is, I'm going to show you how it works. I'm going to make it super hard, and then I'm going to show you the easy way. So I take whatever that square root 5 is, I'm going to multiply it both in the top and bottom. And what happens is that you have this on the top, and then you have square root 5 and square root 5. What happens there is that you got 5 times 5, both on the inside of the square root. Well, essentially, that's a 25. And what's the square root of 25? Is 5. And so this is the actual answer that my math lab is wanting. You could skip to the end by just saying, hey, here, I'll visualize it here with you. I'm going to take the square root of 5 and pop it in the top, but I leave the number behind. Done. Done. So you don't have to do that long method all the time. Pop it in the top, leave the number behind. That's called rationalizing your denominator. And they're going to say that phrase in the blue little hint thingies in my math lab. And they'll basically want that for the entire class. So whenever you see me do it, I'll be doing it. Okay, on to some kind of like formula things. And these are kind of fun. Again, I'm using all these formulas that are listed on that page on the unit circle. So I got sine of 30 times cosecant of 30. Well, the cosecant of 30 is 1 over sine of 30. That's the formula, I guess. So you can say cosecant is equal to 1 over sine. Again, another formula. There's tons of these formulas. I can't write them all up here, but you can definitely have a big list. Well, what happens in this case is that you have sine 30 cancel, leaves a 1 behind. And that's your answer. So that was pretty easy. I like these easy ones. These are fun. 5 to 31. So I've got sine of 25 degrees, and it says write the co-function. Co-function. So when I say sine and they say co-function, they mean cosine. I guess there you go. That's how you say it. Which is just cos, I guess. They're saying cosine. Now, there's a formula for this. There's always a new formula. And it's actually really simple formula. It's here. I'll actually write the formula. Here we go. So sine of theta is equal to cosine of 90 degrees minus that theta. And so in our particular case, I'm going to say I got the 90 degrees minus 25 degrees. It makes a 65 degrees. Now, what my math lab's wanting you to do is put a 65 in there, and that's it. So you're done. So there's your formula. There's, again, lots of formulas. I could list them out all day long, but I recommend you going and finding them in that formula book. And once you have that single page full of all of them, you're really good to go. Cosecant of 38 degrees, write the co-function. Now, it's already a cosecant. And so the co, it's like co of a co makes an unco. Like two negatives make a positive. And so its co is a secant. Well, this is very simple to do. Same as the last time. 90 minus now the 38. And I got secant of, and what do they want here, is a, zoom in, 52. Okay, let me zoom out a tiny bit again. Cool. Next one, 5 to 47. I actually have a note right here that says use a calculator. And I'm like always saying Desmos Scientific. I have a little calculator on my own over here, but I'm just basically Desmos Scientific, okay? They want to find what's the cotangent of pi over 8. They say go. Now, Desmos Scientific will not accept that cotangent like that. It just doesn't like it. And so what you have to do is understand that it's simply the same as saying 1 over the tangent of pi over 8. So you could type that in the Desmos Scientific, and it works. And so what I got was a 145.9002, a 2.4142, ding, ding, ding. Okay, what? What just happened? So on Desmos Scientific, they have a button that it kind of looks like this, and it says degrees. And if you click it, then it looks like this, and it'll say radians. And then you'd have to click it again, and it like flips back and forth. What you want is radian mode. You want to make sure it says radians. And so it's by default degrees. So you need to click that little button to make it into radians. Isn't that a radian value? I mean, it's got pi's and stuff, right? So when you're doing this problem, make sure to put it in the radian mode and then you type it, and it should give you the right answer, okay? Now, let's just say you type this into my math lab homework, and it says, no, you're wrong. Well, just click the button, and there you go. Try the other one. One of them's got to work. Keep cruising. 5, 2, 49. I've got a triangle that looks something like this. 38 degrees. This is 310 centimeters. And they say, what is A equal to? Okay, so let's go back to which one we're going to use. We need to say, are we going to use a sine, are we going to use a cosine, or are we going to use a tangent for this particular situation? Well, notice that we have the opposite and the adjacent, and the only formula that uses both of those is tangent. And so let me show you how this works. Tangent of 38 degrees is equal to opposite is your A, and adjacent is the 310. So now I need to solve for A. I'm going to multiply this to the other side, so A is equal to 310 times the tangent of 38 degrees. So they want a decimal. And so here we go. It's 242.1985, and that is correct. This is in centimeters now. Remember that this problem now needs to be in degree mode. And so you were just in radian mode. Now go back and flip it to degree mode. If you don't get what this answer is, then it's in the wrong mode. Change your mode on Desmos Scientific. Let's do another one of these where they're choosing, hey, which one of these sine, cosine, or tangents should I be using? So I've got B, and I've got 204 inches. So to find B, should I use sine, cosine, or tangent? I'll wait. It's cosine. So the cosine is the adjacent and the hypotenuse. So cosine of 55 degrees, wow, that doesn't look very good. There you go. Is equal to B is my adjacent, and the 204 is the hypotenuse. Solve for B. Multiply to the other side. So far, pretty easy to find this stuff. 204 cosine of 55 degrees. Again, make sure you're in degree mode. And I got 117.0095. This is in inches now. Cool. Okay. Let's do another type of question. So this is just a whole bunch of new kind of trig questions. This one's definitely calculator, 100% sure. It says sine of theta is equal to 0.6456. And so they're saying, hey, what is theta equal to in degrees? So I have my own way of seeing this problem, and I do it, I don't know, different than some other folks. I'll show you my way, and then I'll show you, I guess, the longer way. No, I'm going to show you the longer way first. Okay, so in order to get theta by itself, what I need to do is I'm going to take the inverse sine of both sides. The inverse sine of both sides. That's sine inverse. Or you could say it's arc sine. So I'm going to write that arc sine or sine inverse. Both of these are fine. Okay, there you go. It just depends on how you're seeing it. But what it's doing is the inverse of this is giving you an angle. Back earlier in this section, or in this, earlier in this lecture, I was saying how all the sine, cosine, and tangents are ratios. Well, now these are angles. I'm getting an angle from a ratio. And I'm doing this inverse thing because inverse sine and sine cancel one another, leaving behind a theta. Now, this is all calculator, all of it. And make sure you're in degree mode because it's going to say, hey, we need degrees. So put it in degree mode. And I got 40.21067 degrees. That's my answer that I'm going to put in the box up there, okay? Not hard at all, not hard. So what is Chad's method? I know. Let me show you. It's maybe a little bit more though. It's faster. Not much faster. I see a sine, and I want theta. And so what I do, and this is not good math, I kind of like move it to the other side in a way. And I just say, oh, I know what I need. I need an arc sine. Boom, and I get the answer. So I don't really need to cancel anything. I'm not really moving it, okay? Math teachers out there, I'm not really moving it. I get it. But I just think of it like this, where I just need to get the other side to be something else. And so I just arc sine. And so maybe it's a failing of mine that I don't cancel both sides every time. I just don't think of it like that. Okay. Either way. Okay. So the next problem is the lake problem. And again, if it gets a name, you know it's a problem. So I'm not going to draw the lake. It essentially comes down to the triangle that they constructed inside of the lake. And it's pretty clear what's going on here. You look at it right here, and this is yards. Okay, and this is an A, solve for A. So, okay, I'm solving for A. I need a sine, a cosine, or a tangent. Which one makes the most sense here? I'll wait. Yeah, it's tangent. I wonder if I did the theme song for Jeopardy, would I get copyrighted out? Would they cancel my video? Anyways, opposite over adjacent. I never thought of that. Multiply to get A, multiply on both sides by the 660. Make sure you're in degree mode. All of this is degrees, so it's degree mode. Type it in. I got a 479.518 yards. And there you go. Cool. Okay, 2 more problems left. 5,277. It's the airplane problem. So it's a really thin triangle. I got 7 degrees right here. And then there's an airplane, which, here, I'm going to draw an airplane, okay? I don't know. There you go. Totally looks like an airplane. So they're looking for this distance D right here, given that it's 500 feet in the air, and it's 7 degrees. So I need to find the hypotenuse this particular time. All right, sine, cosine, or tangent? It's a sine this time. That's right. So I've got opposite, and I got my hypotenuse. And so sine of the 7 degrees is equal to opposite over the hypotenuse. To solve for D, I move it over, and then I'm actually dividing this back to the other side. I'm kind of like swapping positions. And so it's going to be 500 divided by the sine of 7 degrees. Again, degree mode, put it all into your Desmos Scientific calculator, and you are good to go. I think it's feet. Yeah, it's feet. Okay, so there we go. Last problem. 5,279. So it's the power line problem. So it's a power line. I'm not going to say it. I'm not going to draw it. I'm just going to say power line. So there's a theta here. It says that we have 89 in the wire coming off this. Here, I'll draw the power line. So it has a little branch thingies, where it has all the wires coming in and blah blah blah. Okay, there you go. Anyways, that's a 89. And then its pole is 60, and so what's the angle between the wire and the pole and all that kind of stuff? Okay, so pretty easy here. I have to do sine, cosine, or tangent. Which one makes the most sense here? It's cosine, because I got an adjacent and a hypotenuse. So it says then cosine theta, because I don't know theta, is equal to the adjacent over the hypotenuse. How do I solve for theta? And again, the Chad method is just that, I need to arc cosine both sides. You can cancel it. You can move it over. You can, whatever you want to do, arc cosine, there you go. So I put that into the calculator. Remember degree mode, 47.611 degrees. So done with that. And I'm done with that section. Thank you very much, and have a great day.